Hello everyone, welcome physicists to a lesson dealing with projectile motion. Woo! Like that. Something is shot into the air horizontally and due to gravity it comes down, and with our physics we can figure out things like how far it went. And that is what we're going to do right now, mes amis. This is called another projectile motion problem. Here it is. A rock is thrown horizontally off a cliff as shown. How high was the cliff? What in the world? We can figure that out. Indeed we can. What are we looking for? What's this question actually asking for? That has to be step number one that your brain tries to figure out. It says, how high was the cliff? There are two ways we could answer this question. One thing that we could solve for is d naught y. Initial position in the y. Up here, that was its initial position. So we can find a formula that has a d naught in it, an initial position. Or alternatively, we could find the displacement in the y. Boom, it was up here, it ended down here. I know it goes this way as well, but that's not important. We're talking about d naught or delta d in the y, and so that is this. If we do find that, we have to think, what will be a reasonable answer? Will it be positive? Will it be negative? Well, it depends on the direction. If I make up my direction and it is going down, then it is going to be a negative answer. Right? The displacement will be negative 20 meters in the up direction. Okay? So, we're looking, I'm going to use delta dy. Okay? What are we looking for? Delta dy. What do we know in each plane? Well, horizontally, we know the displacement. It moves 47.5 meters to the right. And we know the velocity. 7.40 meters per second to the right. Okay? And it is not changing. The velocity horizontally is not changing. It's just steady. I know there's actually wind resistance, but it's pretty negligible. We can ignore it. Its velocity in the horizontal is going to be 7.4 the whole time. All right? What about vertically? We are looking for delta dy. What about v naught y? Well, since it was shot horizontally, not up or down, just horizontally, v naught y is 0. Acceleration in the y, it's negative 9.81 meters per second squared in the up direction. Yeah? Or 9.81 down, but we are going to use up as our direction, and so it is negative. Okay. All right. If we are looking for delta dy, there are some very important things to remember. Okay. We're looking for something in the vertical direction. So we need a formula that has no vertical motion in it, no horizontal components. If I have a formula for delta dy, I cannot put any of these numbers in it. Okay? Only these kind of numbers. Okay? Second, the motion in the vertical plane involves acceleration. So if I'm going to have a formula for delta dy, I need an a in my formula. Okay? All right. This formula would work. V naught y times t plus 1/2 at squared. I know v naught y. I know a. I just don't know time. If I know time, boom, put those in, and we've got delta dy. Yeah? How am I going to find flight time? Well, I can't find flight time with my vertical information, because I'm missing something. But I can find flight time with my x information. Okay? And so I'm going to find my flight time based on that, and then put it into here. Okay. Now, I can use this formula to find time. Displacement in the x divided by velocity in the x. Okay, I have both those things. I have rearranged one of my formulas on my formula sheet. I need both vectors in the same direction, so both are to the right. I divide, and I get 6.41 with some more decimal places, seconds. I typically will record all those decimals in case I need them later, and I will here. And then I might write it out otherwise as 6.41 ... Okay, so there are more decimals there. So I can put those numbers in now. V naught y is 0, so 0 times 6.41 seconds is still 0. Plus 1/2, negative 9.81. 6.41, I'm going to put in all those decimal places. Okay, I'm not going to just write 6.41, I need all those decimals. Here I can just write it out as ... That's fine. Seconds bracket squared. Okay, this square is something that's easy to forget, so don't forget that. Throw it in your calculator or do mental math, and boom, we get negative 202.098 ... meters up. Okay, so that is the displacement. Right? The displacement was negative 202 meters up. So then, and to 3 sig figs, it would be 202. I have to use 3 sig figs because I had 3 sig figs in my question. And so if the displacement is negative 202 meters up, the initial height must have been 202 meters high. So that's a quick example of how to do these types of problems. And they're all fairly similar, but you can get different variations of these. But hopefully that is helpful. And I encourage you to just make sure you show all your steps. Don't lose marks on things like units and directions and vector arrows and sig figs. Yeah, you're going to do great. Take care.